If you're using Kubernetes, Docker, or microservices, chances are your apps expose metrics in Prometheus format. But here's the catch. Hook those into Datadog the wrong way, and you could end up with thousands of custom metrics and a bloated bill. In this video, I'll show you how OpenMetrics works, how to use it smartly with Datadog, and how to avoid common mistakes. By the way, Prometheus and OpenMetrics integrations are very similar, but we recommend using OpenMetrics where possible. It's the newer standard and better aligned with Datadog's support model. But before getting started, what is OpenMetrics? OpenMetrics is the open standard that Prometheus helped pioneer. It's a simple text-based format that apps can use to expose their metrics on a /metrics endpoint. Tools like Kubernetes and Envoy use this by default. It's becoming the de facto way to share metrics in open systems. And the good news is, Datadog can ingest OpenMetrics. But before you turn it on, there's something important to understand. If Datadog offers a native integration, like for Kubernetes, Redis, Postgres, use that first. Native integrations send standard metrics that don't count against your custom metrics quota. But OpenMetrics-based integrations or Prometheus-based integrations, they count as custom metrics. And custom metrics cost extra, which can impact your monthly bill at scale. So, before you start scraping everything that emits Prometheus, check if there's a built-in integration. Use native when you can. Now, if you're already using Datadog and you're unsure which metrics are costing you money, or even if they're being used, check out Dataiker. It's a tool that helps you optimize your Datadog setup. It tells you which custom metrics are used in dashboards or monitors, and even gives you recommendations to reduce waste. So before you start plugging in more metrics, make sure your current setup is under control. Link in the description if you want to try it out. Now that we've covered the theory, let's walk through a live demo. Here's a simple app I put together. It's an express.js app with endpoints like /health, /metrics, and /demo, and some of them generate metrics. For example, this one's a counter for the operation type. And over here, we've got an observed value and a gauge as well. The idea is, once I start generating traffic, I'll be able to observe those metrics flowing through the system. The app is containerized, so I just run docker compose upd to get it going. Within a few seconds, everything spins up, and the app is now live on port 3000. Now, if we hit the /health endpoint of our app, we get a specific response. It returns a simple JSON output showing the status as healthy, along with the current timestamp. The /demo endpoint is just a simple dummy API returning a JSON response. The /API/data route isn't implemented yet. The /metrics endpoint is the key one. It's what Prometheus will scrape, and some of the metrics there update automatically as traffic comes in. To understand how this works, let's examine the output of the /metrics endpoint. As mentioned earlier, here's the output of my /metrics endpoint, and you can already see how OpenMetrics is structured. Each section defines a metric type. For example, here we've got http_requests_total, which is a counter. You can see the method used, the route hit, and the status code. In this case, it's 200, and we've got 7 requests recorded. Each of these lines represents a distinct metric. Even if they share the same name, they're counted separately. In Datadog, that means nearly every line counts towards your custom metric quota. For example, here we've got 6 metrics, over there quite a few more, here just 1, and in this section 4 more. Tags are everything inside the curly braces. Those are the key value pairs that will show up as tags in Datadog. So far we've looked at a counter. Next up is a histogram, a bit more complex, and we'll break it down shortly. And at the bottom, we also have a gauge. These 3, counter, histogram, and gauge, are the main metric types in OpenMetrics. With the concepts covered, let's now configure our first OpenMetrics integration in Datadog. Let's take a look at the basic setup. If we run cat docker compose.yml, you'll see the agent configuration, and more importantly, the OpenMetrics integration settings. At the top, we're collecting logs from a specific container, which is not part of this demo's scope. The rest of the file focuses on configuring the OpenMetrics integration. Here you can see the minimal configuration, pointing to the OpenMetrics endpoint on my container host on port 3000 at the /metrics path. For this example, we're collecting all available metrics to start with. We've also added a namespace, a prefix that gets applied to each metric to help group and identify them. With that in place, I just run docker compose up and the app is live. Now, once I generate some traffic, I can confirm via a Docker command that both Prometheus log collection and the OpenMetrics integration are up and running. Both components are fully set up. Now if you check the /metrics endpoint from the app, you'll see 5 metric names being collected. 1, 2, 3, 4, 5. They're actively changing over time. And if you head over to the metrics summary view, you'll see them listed under the namespace we defined, OpenMetrics_app. And here's the full list. I pulled them into a dedicated notebook so we can start observing their behavior. We've got active connections, memory usage, and request duration, which I chose to break down by endpoint. That's why you see different colors. Each one represents the number of requests for a specific endpoint. There are a few more parameters worth knowing about. Let's walk through them. If you open the default config file for OpenMetrics under Integration Core at this path, you'll find all the available options for configuration. We'll walk through a few key ones, since they're the most critical to get right. Let's jump straight to the instances section like we saw earlier. The OpenMetrics_endpoint is key. You need to make sure it points to the right target. Adding a namespace helps categorize metrics by app, so it's good practice to include a clear prefix. And finally, the metrics field defines what gets collected. In our setup, we're using .star, but keep in mind, regex expressions are supported. That means you can selectively pull metrics. For example, you could use http.star to collect just the HTTP-related ones and skip the rest. At this point, you can also exclude metrics. I usually recommend starting small. Custom metrics can get expensive, so it's smarter to begin with a minimal set and scale gradually. Earlier, we used .star to collect everything, which I don't generally advise. Instead, go step by step and allow list only the metrics you really need. Here's what I did in my Docker Compose. I moved away from the .star approach, commented it out, and instead explicitly listed only the metrics that mattered to me. For HTTP requests, since there are a few variations, I used a http_requests.star pattern to catch them all. This approach is much more manageable and helps keep your custom metric count under control. Just so you're aware, I skipped a few lines, but the config also includes authentication options. Depending on your system, you can use something like basic auth with a username and password. It's worth mentioning, since auth is often required in production environments, toward the bottom of the config, you'll find some other useful parameters. You can define tags, for example, the owner, the team, or a specific service name. Adding these ensures your metrics arrive in Datadog with the right context, which makes them much easier to filter and manage later. Time to talk about histograms, a core OpenMetrics type that's perfect for measuring things like latency. Another useful section gives you fine-grained control over how histograms are collected and processed, and there are several config options worth exploring. In this example, though, we'll try out a few of them and see how they behave directly in the platform. If you check the Docker Compose, you'll notice we've set up 3 separate OpenMetrics integrations for our container. Each of these integrations uses a different config approach. The first one collects the histogram and buckets exactly as they appear on the /metrics endpoint. The second sets non_cumulative_histogram to true. And the third adds the option to collect histograms as distributions. Now let's see how each setup impacts the way data is visualized. If I head over to the metrics section, you'll see examples of histograms in action. Let's focus on the root demo endpoint since their values by bucket differ, which makes the comparison clearer, so we can visualize them directly inside Datadog. Let's start with the histogram from the first config setup. You'll see we've selected the namespace OpenMetrics.app. At the top, there's the _count metric. It shows the total number of requests over time. Below that are the bucket metrics, which break down that total into latency ranges. These buckets come from the app's config. And here we've got 6 of them, going from 100 milliseconds up to infinity. As you can see, the buckets are being collected properly. They're cumulative, which means if a request falls into the 2-second bucket, it's also counted in the 5-second one, and so on. That's why the higher buckets will always have equal or greater values. One challenge with cumulative buckets is that an increase doesn't always mean something good or bad. It depends on which bucket moves. If the 5-second bucket increases but the ones below don't, that's a bad sign. But if the 100 millisecond bucket increases, it means most requests are going below 100 milliseconds. And that's great even if the higher buckets increase as well. Interpreting these buckets takes a bit of abstraction. You need to understand the full distribution to draw the right conclusions. In the second config setup, we've enabled non-cumulative histogram buckets. That means we're not aggregating like OpenMetrics does by default. Each bucket stands on its own with a defined upper and lower bound. If we scroll down in the data, you'll see each metric clearly shows its range, making it easier to interpret. This makes it much easier to tell whether a change is good or bad. For example, an increase in the lower buckets is generally a positive sign, much better than seeing growth in the higher latency buckets. With clear bounds, you can quickly spot whether latency is trending, whereas with cumulative buckets, they're not isolated. So you have to mentally track how the other buckets shifted to understand the full picture. Now let's look at the final configuration. Here, the only change is that we've enabled histogram underscore buckets underscore as underscore distributions. You won't notice a huge visual difference. The spikes vary slightly due to timing differences in when the integrations were set up. What really matters is this. If you head to the metric summary and look at the duration metrics, you'll see they're now typed as distributions, and that means we can enable percentiles. This makes it much easier to explore and interpret the data. Now that we've enabled distributions and percentiles, we can duplicate this graph. Then just edit it, remove the specific filter, and now we've got access to everything. You can easily visualize P90, P95, and more right in the platform, making it much easier to read and interpret. And with that, we made the interpretation of the graph a lot simpler. Any spike in the percentile latency graph means an increase in latency. It's usually a red flag. So definitely take advantage of this. Just one final note. Distributions do cost a bit more than standard buckets, but the clarity they provide makes troubleshooting and onboarding significantly easier for your entire team. Just to demonstrate, I waited a bit and then plotted P95, P90, and P50 across both setups. You can clearly see how they differ in behavior. As always, P90 is one of the most useful views. It gives you a clear read on latency and helps spot whether things are running smoothly or not. Here's the bottom line. Use native integrations when available. Don't scrape everything, allow lists smartly. Use namespaces and filters. Watch your custom metrics usage. Let Datadog turn histograms into readable distributions. OpenMetrics is powerful, but you need to be deliberate. If you found this useful, hit like and subscribe. And check out the link in the description for more Datadog tutorials. Meanwhile, happy monitoring